Welcome to the History of Simple Things, where we delve into the fascinating history behind the little things that shape our world. Television, often regarded as one of the greatest inventions of the 20th century, has revolutionized the way we consume information and entertainment. From its humble beginnings to the modern-day smart TVs, the journey of television is a fascinating tale of innovation, technological advancements, and cultural impact. In this video, we will take a deep dive into the detailed history of television, exploring how it has evolved over the decades. The concept of television can be traced back to the late 19th and early 20th centuries. The journey began with the discovery of electromagnetism by James Clerk Maxwell in the 1860s, which laid the foundation for the transmission of images over distances. However, it was the work of several inventors and scientists in the early 20th century that truly paved the way for television as we know it. One of the key figures in the development of television was Paul Nipkow, a German engineer, who invented the Nipkow disc in 1884. This mechanical device used a rotating disc with perforations to scan images and transmit them through a series of electrical impulses. Although rudimentary, Nipkow's invention was the first attempt at creating a working model for television. The early 1920s saw significant advancements in television technology. John Logie Baird, a Scottish inventor, is often credited with creating the first working television system. In 1925, Baird successfully demonstrated the transmission of moving images using a mechanical system. His work culminated in the first public demonstration of a television in 1926 in London, where he showcased live moving images to a captivated audience. Meanwhile, in the United States, Philo Farnsworth, a young American inventor, was making strides in electronic television. Farnsworth developed the first fully electronic television system, which used a device called the image dissector to capture moving images and convert them into electronic signals. In 1927, he successfully transmitted the first electronic television image, a simple line, thus marking a significant milestone in television history. Another pivotal figure was Vladimir Zworykin, a Russian-American engineer who worked for the Westinghouse Electric Corporation and later for RCA, Radio Corporation of America. Zworykin developed the iconoscope, an early form of a television camera tube, which significantly improved the quality of transmitted images. His work, along with Farnsworth's, laid the groundwork for the electronic television systems that would dominate the mid-20th century. The 1930s and 1940s were crucial decades for the development and commercialization of television. With technological advancements and the establishment of broadcast standards, television began to transition from experimental demonstrations to a mass medium. In 1936, the BBC, British Broadcasting Corporation, launched the world's first regular high-definition television service, broadcasting from Alexandra Palace in London. The service used Baird's mechanical system initially but soon switched to the all-electronic Marconi EMI system, which offered better picture quality. This marked the beginning of scheduled television programming and set the stage for future developments in broadcast television. In the United States, the Federal Communications Commission, FCC, played a significant role in the standardization and regulation of television broadcasting. In 1941, the FCC approved the NTSC, National Television System Committee, standard for black and white television, which defined the technical specifications for broadcast signals. This standardization was crucial for the widespread adoption of television as it ensured compatibility between different television sets and broadcast signals. World War II temporarily halted the progress of television, but the post-war era saw a rapid expansion of the medium. The late 1940s and early 1950s were marked by the establishment of major television networks such as NBC, National Broadcasting Company, CBS, Columbia Broadcasting System, and ABC, American Broadcasting Company, in the United States. These networks began to produce and broadcast a variety of programs, including news, sports, dramas, and comedies, which attracted a growing audience. The 1950s also witnessed the introduction of color television. While the concept of color television had been explored as early as the 1920s, it wasn't until the development of the NTSC color standard in 1953 that color television became commercially viable. The first color broadcast in the United States took place in 1954, and although color television sets were initially expensive, they gradually became more affordable and widespread. The 1950s and 1960s are often referred to as the golden age of television. During this period, television became a dominant form of entertainment and a powerful cultural force. This era saw the rise of iconic television shows, the expansion of television networks, and significant advancements in production techniques. One of the defining characteristics of the golden age of television was the emergence of anthology drama series. Shows like Playhouse 90 and The Twilight Zone brought high-quality original storytelling to the small screen, often featuring prominent writers, directors, and actors. These shows pushed the boundaries of what television could achieve in terms of narrative complexity and artistic expression. News and current affairs programming also gained prominence during this era. Edward R. Murrow, a pioneering broadcast journalist, set high standards for television journalism with his program See It Now. Murrow's fearless reporting and incisive interviews brought critical issues to the forefront and demonstrated the power of television as a tool for informing the public. Technological advancements during this period further enhanced the television viewing experience. The introduction of videotape recording in the late 1950s revolutionized television production, allowing for the editing and preservation of programs. This technology also facilitated the growth of syndication, where television shows could be sold and broadcast across different markets, extending their reach and popularity. The golden age of television also saw significant changes in the way television content was consumed. The proliferation of television sets in households meant that television became a central part of daily life. Family members would gather around the TV to watch their favorite shows, creating a shared cultural experience. The influence of television on popular culture was profound, shaping fashion, language, and social attitudes. The 1970s and 1980s brought significant changes to the television landscape with the rise of cable and satellite television. Cable television, initially developed to provide TV service to remote areas, began to offer a wider array of channels and improved picture quality. The introduction of premium cable channels like HBO in the 1970s provided viewers with access to movies and exclusive content not available on network television. Satellite television also emerged as a major player during this time. Early satellite systems were primarily used for commercial and government purposes, but by the late 1970s, consumer satellite dishes became available. This allowed viewers to access a wide range of channels from around the world, further expanding the variety of programming available. The 1980s saw the rise of cable networks like CNN, MTV, and ESPN, which specialized in news, music, and sports, respectively. The introduction of pay-per-view services also allowed viewers to watch special events like boxing matches and concerts from the comfort of their homes. The late 20th and early 21st centuries witnessed the digital revolution, transforming the television industry once again. The transition from analog to digital broadcasting began in the late 1990s and was completed in many countries by the mid-2000s. Digital television offered superior picture and sound quality, as well as the ability to broadcast multiple channels in the same bandwidth. High-definition television, HDTV, became the new standard, providing a much clearer and more detailed picture than standard definition television. The introduction of flat-panel display technologies, such as LCD and plasma screens, further enhanced the viewing experience. These new televisions were thinner, lighter, and more energy efficient than their cathode ray tube (CRT) predecessors. The rise of the internet also had a profound impact on television. Streaming services like Netflix, Hulu, and Amazon Prime Video emerged in the late 2000s, offering viewers the ability to watch a vast library of content on demand. This shift from scheduled programming to on-demand viewing disrupted traditional television business models and changed the way people consumed media. The introduction of smart TVs, which could connect to the internet and run apps, further blurred the lines between television and computer screens. As we look to the future, the television industry continues to evolve with new technologies and trends shaping the way we consume content. From advancements in display technology to the integration of artificial intelligence, the future of television promises exciting possibilities. The history of television is a remarkable journey of innovation, creativity, and cultural impact. From the early experiments of Nipkow and Baird to the digital revolution and the rise of streaming services, television has continually evolved to meet the changing needs and preferences of viewers. As we look to the future, advancements in technology and the integration of artificial intelligence promise to further transform the television landscape. The rise of interactive and immersive experiences will provide new ways to engage with content, creating a more personalized and dynamic viewing experience. Television has come a long way since its inception, and its future is full of exciting possibilities. Whether through traditional broadcast, cable, or streaming services, television will continue to be a central part of our lives, entertaining, informing, and inspiring audiences around the world. Thank you for joining us on this journey through the history and making of television. If you enjoyed this video, please keep tuning in for more in-depth explorations of the technologies and innovations that shape our world. Hello, everyone. Today, we're diving deep into a fascinating topic that has shaped our world in numerous ways: the history of AM/FM radio. From its humble beginnings in the late 19th century to becoming a ubiquitous part of our daily lives, the evolution of radio technology has been nothing short of revolutionary. So sit back, relax, and let's journey through time to explore the milestones, the key figures, and the technological advancements that have defined AM and FM radio. Our story begins in the late 19th century with the discovery of electromagnetic waves. James Clerk Maxwell, a Scottish physicist, predicted the existence of these waves in 1864. His theoretical work laid the foundation for the practical development of radio. However, it wasn't until 1886 that Heinrich Hertz, a German physicist, proved Maxwell's theory by demonstrating that electromagnetic waves could be transmitted and received through space. Guglielmo Marconi, an Italian inventor, is often credited with the invention of the radio. In 1895, he successfully sent and received his first radio signal in Italy. Marconi's early experiments were rudimentary, but they quickly evolved. By 1901, he had transmitted the first transatlantic radio signal from Cornwall, England, to Newfoundland, Canada. This achievement marked the beginning of long-distance radio communication. Simultaneously, other inventors were making significant contributions. Nikola Tesla, for instance, demonstrated wireless communication in 1893. Despite a legal battle over patent rights with Marconi, Tesla's work was crucial in the development of radio technology. Another key figure was Reginald Fessenden, who, in 1906, made the first audio broadcast, transmitting voice and music over the airwaves. AM radio, or amplitude modulation radio, was the first type of broadcasting used for audio transmission. The term amplitude modulation refers to the method of encoding audio information onto a carrier wave by varying its amplitude. This method was developed in the early 20th century and became the standard for radio broadcasting. In the United States, the first commercial radio station, KDKA, began broadcasting in 1920. Located in Pittsburgh, Pennsylvania, KDKA made history by airing the results of the 1920 presidential election. This event is often considered the birth of modern radio broadcasting, as it demonstrated the medium's potential to reach a wide audience instantaneously. Throughout the 1920s and 1930s, AM radio stations proliferated across the United States and the world. These stations provided not only news and entertainment, but also a platform for political discourse and cultural exchange. Radio became an essential part of everyday life, especially during times of crisis, such as the Great Depression and World War II. During the golden age of radio, roughly from the 1930s to the 1950s, radio was the dominant medium for entertainment and information. Popular shows like The Shadow, The War of the Worlds, and The Lone Ranger captivated audiences. Radio personalities and announcers became household names, and the medium's influence on public opinion and culture was profound. Despite its popularity, AM radio had several limitations. One significant issue was interference. AM signals are susceptible to electrical interference from storms, power lines, and other sources. This interference can degrade the audio quality and make listening unpleasant. To address these issues, engineers and inventors continued to innovate. One of the most significant advancements was the development of frequency modulation, or FM radio, by Edwin Howard Armstrong in the 1930s. Armstrong's FM technology offered several advantages over AM. It provided clearer sound quality, reduced static and interference, and allowed for the broadcasting of higher fidelity audio. However, the adoption of FM radio was slow. AM radio was well established, and many broadcasters were hesitant to invest in new technology. Additionally, the commercial infrastructure for FM broadcasting needed to be built from scratch. Despite these challenges, FM radio slowly gained traction, particularly in the 1960s, when the Federal Communications Commission, FCC, in the United States began to support its development more actively. FM radio's rise to prominence was fueled by several factors. The superior sound quality of FM broadcasts made it ideal for music programming. As the popularity of rock and roll and other music genres grew in the 1960s, so did the demand for high-fidelity audio, which FM radio could provide. FM's growth was also supported by regulatory changes. In 1965, the FCC mandated that FM stations in larger markets could no longer simply simulcast their AM counterparts. This rule encouraged the development of unique FM programming, which attracted a new audience and spurred the growth of FM broadcasting. By the 1970s, FM radio had become the preferred choice for music lovers, while AM radio continued to serve primarily as a platform for news, talk shows, and sports broadcasting. The two bands coexisted, each catering to different segments of the audience. This period marked the diversification of radio content, with FM stations often pushing the boundaries of programming creativity. Radio's impact on culture and society has been profound. During its early years, radio was a unifying force, bringing people together to experience news, music, and entertainment. It played a crucial role during World War II, providing updates from the front lines and boosting morale with patriotic programming. In the post-war era, radio continued to shape public opinion and culture. The 1950s and 1960s saw the rise of radio DJs who became influential tastemakers. Personalities like Alan Freed and Wolfman Jack introduced audiences to new music styles and artists, driving the popularity of rock and roll, rhythm and blues, and other genres. Radio also served as a platform for social change. During the Civil Rights Movement, radio broadcasts helped spread the messages of leaders like Martin Luther King Jr., mobilizing support and raising awareness. Similarly, in the 1960s and 1970s, FM stations became hotbeds of countercultural activity, promoting the ideals of the era's social and political movements. The evolution of radio technology didn't stop with AM and FM. The late 20th century and early 21st century saw the introduction of new broadcasting technologies, such as digital radio and satellite radio. These innovations aim to address some of the limitations of traditional radio and offer new features to listeners. Digital audio broadcasting, DAB, emerged in the 1990s, providing higher audio quality and more efficient use of the radio spectrum. DAB allows for the transmission of multiple channels on the same frequency, expanding the variety of available content. Despite its advantages, DAB adoption has been uneven globally, with some countries embracing it more fully than others. Satellite radio, launched in the early 2000s, offered another significant advancement. Companies like SiriusXM provided nationwide coverage with hundreds of channels, including commercial-free music, talk shows, and specialty programming. Satellite radio's subscription model allowed for a more tailored listening experience, free from the constraints of traditional advertising-driven radio. Today, radio exists in a multifaceted media landscape. Traditional AM and FM stations continue to operate alongside digital and satellite services. Additionally, the advent of the internet has transformed radio once again. Online streaming services, podcasts, and internet radio have broadened the scope of what radio can be. Streaming platforms like Spotify and Apple Music offer vast libraries of music and podcasts, providing listeners with unprecedented control over their listening experience. Internet radio services such as Pandora and iHeartRadio allow users to customize stations based on their preferences, blending the traditional radio format with modern technology. The history of AM/FM radio is a story of innovation, perseverance, and cultural impact. From the early experiments of Marconi and Tesla to the rise of FM radio and the advent of digital broadcasting, radio has continually adapted to meet the needs of its listeners. As we navigate the ever-changing media landscape, radio remains a vital and dynamic medium, reflecting and shaping the world around us. The history of electrical outlets is a fascinating journey through technological evolution, cultural preferences, economic considerations, and geopolitical realities. When you travel internationally, one of the most common and sometimes frustrating experiences is dealing with different electrical outlets and voltage standards. It's a problem that seems so unnecessary in our modern, interconnected world. Why isn't there a single universal standard for electric outlets? To answer this question, we need to delve into the complex history of electricity, the development of electrical systems, and the multitude of factors that have influenced this seemingly straightforward issue. Our journey begins in the late 19th century, during the dawn of electricity. Thomas Edison and Nikola Tesla were among the pioneers who championed different methods of generating and distributing electricity. Edison promoted direct current, DC, while Tesla advocated for alternating current, AC. This rivalry, known as the War of Currents, was about more than just scientific principles. It had significant commercial and practical implications. Edison's DC system had limitations in transmitting power over long distances, leading to higher costs and inefficiencies. Tesla's AC system, supported by George Westinghouse, proved to be more efficient for long-distance power distribution. Eventually, AC became the dominant method of electrical transmission. However, this was just the beginning of the complexities surrounding electrical standards. As electricity began to power homes and industries, different countries developed their own electrical systems based on their unique needs and circumstances. The United States, driven by the early adoption of Edison's DC system, initially developed a 110-120-volt, 60 Hz AC standard. This decision was influenced by various factors, including the existing infrastructure and economic considerations. In Europe, however, different countries had different needs and preferences. Germany and other countries adopted a 220, 240-volt, 50 Hz AC standard. The higher voltage allowed for more efficient power distribution, which was particularly important in densely populated and industrial regions. These early decisions were made independently and were influenced by the technologies available at the time, the existing infrastructure, and the priorities of each country. Once a country established its standard, changing it would have been extremely costly and disruptive. Thus, these early decisions set the stage for a lack of uniformity in electrical standards. The aftermath of World War II saw significant rebuilding and development across many parts of the world. This period was a critical moment for the standardization of electrical systems, as nations had the opportunity to modernize and possibly align their systems. However, geopolitical divisions, such as those between the Eastern and Western blocs during the Cold War, further entrenched differences in electrical standards. In Europe, efforts to standardize within the continent led to the adoption of the International Electrotechnical Commission (IEC) standards. However, even within the IEC framework, variations persisted. The United Kingdom, for instance, maintained its unique BS 1363 socket and plug design, which was different from the rest of Europe. In the United States and Canada, the North American standard continued to dominate, with the National Electrical Manufacturers Association, NEMA, developing a range of plug and socket configurations tailored to different power needs. This further solidified the differences between North American and European standards. As technology advanced and consumer electronics became more widespread, the differences in electrical standards became more apparent and problematic. Manufacturers had to produce different versions of their products for different markets, which increased costs and complexity. This was particularly evident in the rise of personal computing and other electronic devices that required reliable and consistent power sources. In the late 20th and early 21st centuries, global trade and travel increased exponentially, bringing the issue of non-standardized electrical outlets to the forefront for many consumers and businesses. Travelers needed adapters to use their devices abroad, and multinational companies had to navigate the complexities of different electrical standards in their operations and product lines. Despite the inconveniences and additional costs, the entrenched differences in electrical standards proved difficult to overcome. The existing infrastructure, combined with regulatory and safety considerations, made the prospect of transitioning to a universal standard daunting and impractical for most countries. One of the key factors preventing the adoption of a universal standard is safety. Electrical systems are designed with specific safety features to protect users from shocks, fires, and other hazards. These safety features are deeply integrated into the design of plugs, sockets, and electrical wiring. Any change to the standard would require a comprehensive overhaul of these systems, which would be costly and potentially dangerous if not executed perfectly. Regulatory bodies in each country have developed stringent standards to ensure the safety and reliability of their electrical systems. Changing these standards would require international cooperation and consensus, which is challenging to achieve given the diverse interests and priorities of different nations. Furthermore, the differences in voltage and frequency between regions complicate the issue. North America's 120-volt 60 Hz system is fundamentally different from Europe's 240-volt 50 Hz system. Aligning these standards would require significant changes to the electrical infrastructure, including power generation, transmission, and distribution systems. Economic and political factors also play a significant role in the lack of a universal standard for electrical outlets. Countries have invested heavily in their existing infrastructure, and transitioning to a new standard would require substantial financial investment. This investment would need to be justified by significant long-term benefits, which are difficult to quantify given the complexity of the issue. Political considerations, such as national sovereignty and the desire to maintain control over critical infrastructure, further complicate the possibility of international standardization. Countries are often reluctant to cede control over their electrical standards to an international body, fearing that it could lead to a loss of autonomy and influence. Additionally, there are vested interests within each country that benefit from the existing standards. Manufacturers, electrical contractors, and regulatory bodies all have a stake in maintaining the status quo, which creates resistance to change. Despite the challenges, technological solutions have emerged to address the issue of non-standardized electrical outlets. Universal power adapters and converters allow travelers to use their devices in different countries, mitigating some of the inconvenience caused by differing standards. These devices are designed to handle different voltages and plug configurations, providing a practical solution for international travelers. In the realm of consumer electronics, manufacturers have developed dual-voltage devices that can operate on both 110, 120 volts and 220, 240 volts. These devices are equipped with power supplies that can automatically adjust to different voltages, making them compatible with multiple electrical systems. Looking to the future, advances in wireless power transmission and other emerging technologies could potentially reduce the reliance on traditional electrical outlets. Wireless charging pads and other innovations are already making it possible to power devices without the need for physical plugs and sockets. While these technologies are still in their early stages, they offer a glimpse of a future where the need for standardized electrical outlets may become less critical. The lack of a universal standard for electrical outlets is the result of a complex interplay of historical, technological, economic, political, and safety factors. The early decisions made during the development of electrical systems in the late 19th and early 20th centuries set the stage for the diversity of standards we see today. Efforts to harmonize these standards have been hampered by the significant challenges associated with changing established infrastructure and regulatory frameworks. While technological solutions have mitigated some of the inconveniences caused by differing standards, the prospect of achieving a universal standard for electrical outlets remains elusive. The history of electrical standards is a testament to the complexity of technological progress and the myriad factors that influence the development and adoption of standards. As we look to the future, it is possible that new technologies will change the landscape of electrical power and reduce the need for standardized outlets. Until then, travelers and manufacturers will continue to navigate the complexities of a world with diverse electrical standards. The history of why there is no universal standard for electric outlets is a reminder of the challenges and intricacies involved in creating global systems that meet the needs of diverse societies. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.